Hello, hi student. This is Priya Mahajan, your maths tutor, and once again, I welcome you all on my channel Vidya. So, in the last session, we have started chapter 9, circles of the class 9, of which we have already completed till the theorem 9.1. Now, we'll revise the theorem 9.2. So, theorem 9.2, no need to prove the theorem. We just need to understand what is given in the theorem. Okay. So it is if the angle subtended by the chords at the center, of the circle at the center are equal. Angles subtended by the chords of a circle at the center. Suppose if I will take a circle and this is a center, and if I will take any two chords, suppose I'm taking, let me complete my figure. Yeah, so this is a center and this is a chord AB and chord CD. So I am taking if the angles subtended by the chords of a circle at the center are equal, that is this part is equal to this. This time we have given that angle AOB is equals to angle COD. Then what we have to prove? Chords are also equal. That is, we need to prove that AB is equal to CD. So this is a converse of theorem 9.1. So in the theorem 9.1, we have given the chords are equal and we need to prove that angle subtended by these two chords at the center is also equal. But this time we have given that angles subtended by these two chords at the center are equal and we need to prove that chords are also equal. Okay. So we'll just do the proof of the theorem 9.1, but for the 9.2, it's the converse. No need to do the proof. Okay. Wonderful. Now, let's start the first exercise. So the first exercise we have, recall that two circles are congruent if they have same radii. So congruent means same. So two circles are same when they have the same radius. So let's draw the two congruent circles. So this is the one circle and herein I have taken another circle. Okay. So these are the two congruent circles. Why they are congruent? Because they have the same radius. Now what we need to prove? Prove that equal chords of congruent circles subtend equal angles at the center. So what we need to prove here, if we'll take two chords on the circle, suppose herein I'm taking this chord and herein I'm taking this chord. So these two chords are equal in length. So let's draw the equal chords. And we need to prove that if the two chords are equal, then angles subtended by these two chords at the center is also equal. What we need to prove? Angle subtended by these two chords at the center is also equal, right? Suppose we have taken AB and CD as the two equal chords and O is the center of the first circle and O dash is the center of the second circle. Now what we need to prove here? Angle AOB is equals to angle CO dash D, right? So when we have the questions like to prove, so the steps to write the question is, first of all, we'll write what is given. So herein we have given the two circles AB and two circles having the center AOO, right? And the two chords AB and CD which are equal. So given AB and CD are two equal chords of a circle of congruent circles. We'll say congruent circle. Why congruent circles? Because only in the congruent circles the radius are same. Of congruent circles with center O and O dash respectively. So the first circle has a center O and the second circle has a center O dash, right? Then we'll write what we need to prove. So herein we need to prove that what we need to prove that angle AOB is equals to angle CO dash D, right? This is what we have to prove. So let's prove it. Okay, so we'll take the two triangles. So in triangle AOB and triangle CO dash D, right? Now in both the triangles AO is equals to CO dash because they are the radius and both are the congruent circles. So that is both have the same radius, O dash C. Radii of congruent circles. Similarly, OB is also equals to O dash D. Again, the same reason because both are the radii of the congruent circles. And the third, we have given that AB is equals to CD, right? Why they are equal? Because we have given the two equal chords and both are the chords. So that is using the three equations. We can say that triangle AOB is equals to is congruent to triangle COD by side congruency, right? Now, when the two triangles are congruent, their corresponding parts are equal. And if the corresponding parts are equal, so we can say that angle AOB is equals to angle C dash OD, right? So angle AOB is equals to angle C O dash D. And this is what we have to prove. Hence, proved. I hope it is clear to everyone. Wonderful. So this was the first question. Now we'll start the question number 2. And in the question number 2, we have given, just a second. Yeah, here is the question number 2. So in the question number 2, we have prove that if the chords of a congruent circles subtends equal angle at the center, then the chords are also equal. That is the reverse of the first question. And I think you can solve this question yourself. What is given here? We have given this time the two chords of a circle subtends equal angle at the center. And we need to prove that the chords are also equal. So let's take a circle. Okay. And we'll draw the chords. Suppose this is a one chord. Okay, and herein if I'll draw another chord, and the here is I'm drawing a triangle at the center, and herein the another triangle, right? Okay, now this is a center O, and this is a chord AB, and this is a chord CD. And herein we have given the chords of congruent circles. That is we are taking the congruent circles subtends equal angles at their center. So both will subtends equal angle at the center. Then the chords are also equal. We need to prove that. Then these two chords are also equal. So again, we'll prove the same thing. That is, we'll prove that triangle AOB is congruent to triangle COD using the same process. That is a side. This time we have the angles given. So it will not be side. It will be side angle side. So first step is to write what is given. So this time we have given a circle with two chords AB and CD, which are subtending equal angle at the center. So we'll write a circle with center O and AB and CD are the two chords subtends equal angles at the center. That is what we have given. Angle AOB is equal to angle COD. And what we have to prove? We have to prove that the chords are also equal, right? So let's prove. So again, we'll take the both triangles, triangle AOB and triangle COD. Now, in both the triangles, we can see that the AO is equals to OD, OB is equals to OC, as these are the radii of the congruent circles. AO is equals to OB. Radii of, not OB, this time we'll take another radii of the another circle, that is OD. Next we have OB is equals to OC, again the same reason. And the third, we have given that angle AOB is equal to angle COD. This is given, right? Now we have the two sides equal and the angle included the two sides is also equal. So that means these two sides, these two triangles are congruent to each other. And we know that if the two triangles are congruent, their corresponding sides are equal, corresponding parts are equal. That is AB is equals to CD. And this is what we have to give proof in this theorem, right? So triangle AOB is congruent to triangle COD by side angle side congruency. And if the two triangles are equal, that is their corresponding parts are also equal. So we'll write by CPCT. CPCT means corresponding parts of congruent triangles. Okay. First of all, we have proved the two triangles to be congruent. Then if the two triangles are congruent, their corresponding parts are equal. So we'll prove, we have proved that AB is equals to CD, and this is what we have to prove. All right. I hope it is clear to everyone. Wonderful. So with this, we have completed the first exercise. So in the first exercise, we just have the two questions and both are the theorem based questions. So just practice these questions twice or thrice. Okay. And in case you will have any difficulty in any of the steps, just comment me out. I'll answer all of your doubts. Okay. Okay. Bye-bye. Take care. Have a nice day. Bye.